Functions are a relation. A relation, we said, is just a relationship between numbers. Well, functions are like a special relation. So, like you have in your real life, like you have a bunch of relations. You have your parents and your friends and your cousins and whatever. Well, the function would be like your boyfriend or your girlfriend. It's this special relationship. Okay? Every element in the domain can only go to one element in the range. So for every input, you can only get one output. So if I plug 2 in, I can't get like 5 and 7. I can only get 5, or I can only get 7. Okay, so when we have the mapping, you're going to look at the domain, and you're going to check the number of arrows. As long as there's only one arrow, you're good. Here, we only have one arrow, we're good. Now you can see that 2 arrows go to the 3, but that's okay because it doesn't matter about the range, because 2 different inputs can give us the same output. We just can't get 2 outputs from the same input. So the number of arrows here on the range don't matter. It's only the number of arrows on the domain that matter, and there can only be 1 from each number. When we look at an actual graph, you see how if you look at all the x's, it's only one spot that it's touching on the y. There's not like some other part that curves around. Don't write this down, but it doesn't like curve around and do that, and then we get 2 y's on the same x. It's only got 1 y for each x. So far, we look at here, we have just 1 arrow, so yes, it is a function. Okay, now if you can't tell by just looking, we can set up the mapping. And we list the x's, but we only list each one once. So I have a 2, a 3, and then a 3, and then a 2, so I don't list it again. Oh, okay, I'll go back. Oops, I did 1 already. And I did -2. Okay, hold on, we'll go back.
Okay, it's really fast, I promise, guys. It's like 2 seconds. No.
Just did the domain. There's a 2 and a 3, and I only write them once because it's the same number again. And then there's a -1 and a negative, or a +1 and a -2. I only write those once. So then 2 goes to 1, 3 goes to -2, 3 goes to 1, and 2 goes to -2. So this is not a function because I have 2 arrows coming off of an x. I can only have 1 arrow coming off of the x. So every x can only give me 1 individual y. So if it was like, if it was 2, 3, and then I had something like just the 1 and a -2, and it only did this, then it's a function. But if this then goes here, it's now not a function. So it can only, 1 x, if you put in an x, you can only get out 1 possible y. Okay, so when we look at it this way, I have a 1 and a 4 and a 1 and a -4. These match, but these don't. What on earth is that? So this is not a function. Okay, now if this was a +4 and they were the same, then it would be a function because it would just be the same number repeated again. Does that make sense? So
if the 2 was a -4?
No, if this -4 here, hold on, let me erase those. So so I have 1 +4, and then I have another 1 that goes to a -4. If this -4 was also +4, then it would still be a function because the 1 is giving me 4. But because it's not the same number, it's a different y, it's not a function. Does that make sense? So if it was, we'll just repeat it. If it was like that, then it would be a function because this is the same. It's just repeated. But since it's a negative, it's a different number, and because it's different number with the 2 different y's with the same x, that makes it not a function.
So a function has to be on a scale, it's supposed to be like a straight line.
It doesn't have to be a straight line, it can be a curve. It just can't turn around.
Yeah.
It just can't, you can't have the same x give you 2 different y's. So, like if we talk about like a graph, this is a bad rendition of the square root of x function. It's not a function, sorry, square root of x. Because this x here gives me this y and that y, then it's not a function. Because that's one x, but it has two different y's. So you just can't have that. One x can only give you one y. Okay. Discrete and continuous. Okay, discrete functions are individual points.
You got real good on that.
Thank you.
How long did it take you?
I know.
It took a while. Discrete functions are sets of individual points. The things don't run into each other. Let's look at like the price of apples. Like if one apple is 25 cents, two apples would be 50 cents. You don't have like parts of apples and different prices in between those apples, right? That's you either have an apple or two apples or three apples.
Can't buy half an apple.
Right, or decimals of apples. It's just individual apples. So those would be discrete. Like the cost of apples versus the number of apples you get would be a discrete function. Continuous functions are things that blend into each other. Growing is a continuous function. Height over time, like if you start with a baby and as you grow till you peak out, your growth is gradual. You don't, measure it this month and like tomorrow, like I don't measure my height today and I'm 4 feet. And then tomorrow I'm suddenly 4'4". Like it's not like jumps, it's gradual. And so it blends together. So those are continuous functions. So discrete functions are individual things that don't meld, and continuous functions are things that make gradual changes up or down. Make sense? Okay, so when we look at, we have this example, we have an ice sculpting competition. The sculpture's heights are measured to make sure that it's in the regulated height range of 1 to 6 feet. And the measurements were as follows. Team 1 was 4 feet, Team 2 is 4.5, Team 3 is 3.2, Team 4 is 5.1, and Team 5 is 4.8. Okay, so the domain.
The domain would be the team number?
The teams. So that's the teams. So we have 1, 2, 3, 4, and 5. The range is the height. And so we have 4, 4.5, 3.2, 5.1, and 4.8. Okay, now I'm going to do kind of like a sideways mapping. So is this a function?
Yes.
Yes, because each of the domain only has one arrow comes off. So yes, it is a function. Is it discrete or continuous? It's discrete, right? Because you have individual teams with individual sculptures, and the sculptures are not blending into one another. So it's discrete. Make sense? Bird feeder. Oops, that's supposed to be lowercase h. Okay. The feeder weighs 2.3 pounds when empty, and
It's not, recording.
oh, sorry, thank you. No, yeah, it is. I didn't click the thing right, so it's recording the whole screen. Okay, so it's 2.3 pounds when it's empty, and it's 13.4 pounds when it's full, and it's 3 quarts are full. Okay, with 1 quart of seed, it's 6 pounds. With 2 quarts, it's 9.7 pounds. So we're going to figure out the domain and the range. Okay. The thing that determines, does the amount of seed determine the weight, or does the weight determine the amount of seed?
The amount of seed determines the weight.
Right.
Yes.
Okay. So we have 1 quart, or actually we have 0 quarts, 1 quarts, 2 quarts, and 3 quarts. Because 0 is empty, right? And then when it's empty, it's 2.3 pounds. When it has 1 quart of seed, it's 6 pounds. 2 quarts is 9.7 pounds. And 3 quarts is 13.4 pounds. Okay, so is it a function?
Yes.
Okay, so yes, it's a function. Is that going to be discrete or continuous?
It's discrete. Oh, no, actually, well.
Think about when you have a bird feeder and if it's full. What happens as it empties?
Yeah.
Does a bird come and eat like a whole quart of seed at once? Like, it would be continuous, right? Because birds are going to come and they're going to gradually empty it out. And so the weight and the quarts are going to gradually decrease.
Yeah, when you plot it. Okay.
Yeah, so it's going to be continuous. Because, you know, birds are going to come and they're going to go and it's going to gradually empty. Does that make sense? Okay. So individual dots. But if we graph this, we would have like a point here and then like say 1 here, 1 here, and 1 here, but they would connect because as you, or you could start the other way, but as the seed filled up or as the seed emptied, the weight would be what's changing. Does that make sense? Okay. Now, there's something called a vertical line test. And a vertical line test is how you can tell if a function is, if a graph is a function or not. So what we do is we take a vertical line. And if you take your vertical line and you run it along the graph, it'll only touch in one point. See how it's only touching in one spot? Right? So if a vertical line, straight up and down,
What about the one on the end though?
we'll talk about that one in just a second. Or has an E. So you could like use your pencil or a pen to do this also. If you run your pencil or your pen along the graph, if it touches in one place, it's a function. Now here I kind of drew this not so great and I made it straight up and down on the ends, but it really should be still going out. Here, I touch 1, 2, not a function. Now, this graph is a function, but the only reason it's a function is because this open circle tells me that that point doesn't actually exist. And this closed circle says it does exist. So this is a function. If it looked like this, where I had a closed circle and another closed circle, like that, it's not a function. So if you have an open circle and a closed circle, that's okay. But if you have two closed circles on the same line, it's not. Does that make sense? Okay. Okay, so we haven't gotten into graphing yet, so we're going to have to do this the old-fashioned way. We're going to pick an X.
What does that say?
Find Y. Pick.
Oh, okay.
Yeah.
You can zero any numbers.
Yep. X could be 0, and then I would have -3 times 0 plus Y equals 8, so Y would be 8. And if I plug in X, pick an X and plug it in, and then I can make it, I'll find Y. So I can pick any X to find Y. So if X is 0, I plug in 0 where the X is.
Okay.
3 times 0 is 0.
So can the number be,
I can pick any number for X I want.
Yeah, see, there would be negative, see, she picked 3. -3 times 3 would be.
Want me to do 3? Okay.
We just solve for.
So I get -9 plus Y equals 8. So I add 9 to both sides. And y would be 17. And I'm not going to use that one because my graph only goes to 6. And that would be way up here. But I mean, I'll put it here, but I'm not going to use it. So we want to try to find something that's going to give me a smaller y. Well, 0 went all the way to 8. And 3 goes all the way up to 17. So why don't we try numbers smaller than 0?
-2.
All right, -2. And -3 times -2 plus y equals 8. So that's
There's 2 negatives, that means you add.
Oh. 5,
multiplying.
8.
So
You want a -6.
a -6, so y is going to be 2. So I get -2, 2. We need one more point to make a line.
-4.
Okay, so I get -3 times -4 plus y equals 8. Yep, so 12 plus y equals 8. So if I subtract 12 from both sides,
You get 4.
-4. So -4 gives me -4. And I know that 0 was going to give me 8, which is like up here somewhere or something. And I'm going to connect my dots.
It's a function.
And that's really actually there. So 8 would really be here.
Okay, perfectionist.
Yes. And if I give myself the vertical line test, so the vertical line test, you can just look at all of these lines going up and down on the x.
So you choose whatever you want.
For x.
Make it
And then you
whatever
find,
want.
yeah, you pick any number for x at all. And then you just find out what y has to equal. So
You do the same for y.
you could pick any y and find x too. It's just usually easier to pick x and start from there. But you could go the other way. That's fine. So we have this line. There's no double crossing on the vertical line test, so yes, it is a function. For that, okay, so 4x equals 8, so that means x equals 2. Now how do we graph this on a coordinate plane? X equals 2. Now, if y is 0, x equals 2. What if y is 1? Well, x still equals 2 because y is not even on there. So we get x equals 2 all over the place. So my line goes like that. Did I pass the vertical line test? If my line is going straight up and down, it is a vertical line. So if I run a vertical line along it, it's going to be the same, right? So this is not a function. Because x always equals 2 no matter what y is. And so there's like a gazillion points here. It's an infinite number of points, actually. Gazillion's not even a real word. So it never stops. So this is not a function. Any vertical line is not a function. And vertical lines are always x equals a number. So anytime you get x equals a number, you're going to have a vertical line. It's not going to be a function. Make sense?
What did we need this for?
I'll give it to you. I'm giving you a question at the end.
It's our attendance.
Yeah, I do attendance. Finding the value of a function. Okay, function notation replaces y. Okay, f of x and y are the same thing. And what this is saying is function of x. If you see this, you know you have a function. So if I were to say, like this question right here, is this a function? You just go, well, yes, it is, because that means it's a function. Okay? So the equation maybe is y equals 2x plus 1. In function notation, it would be f of x is equal to 2x plus 1.
So the function is y.
Yeah, y and f of x are the same thing. Now, you won't have an equation that is like, it's like be 2x plus 3y equals 10. It won't be like 2x plus 3 f of x it doesn't do that. It's always f of x equals. Yes.
Why?
Why?
Yeah, why?
Because this allows us to find the value of this for various forms of x quickly and easily. The notation is a shortcut, it's shorthand.
Okay.
So that what I do is I don't have to say find the value of y equals 2x plus 1 if y equals 7. I can just say find f of 7. And then that is shorthand.
And then we'll automatically make it that function.
Yeah, and it's just shorthand. So it's like this. We say find, if we have a function, f of x equals negative 4x plus 7, we want to find f of 2. What we do is we replace x with 2. That's what happens, is whatever's in this parenthesis goes where x was. So it's f of 2 is negative 4 times 2 plus 7. So I took this negative 4x plus 7, I put 2 in instead. So that's negative 8 plus 7, so that's negative 1. Okay. If something's happening outside, like this plus 1 I tacked onto the end, for this one I replace x with negative 3.
Why?
And then I add 1 to the end, because that's happening outside. It's just a shorthand for the notation. It's telling you to find this function if I make y negative 3 and I add 1 to it. It's just shorthand. It's just a way to write things shorter. So what I do is I take the 3 or the x out. I put the negative 3 in, plus 7, that's the part that already existed, right? And then there's this plus 1. So I'm going to tack a plus 1 onto the end. Because that was outside. Oops, sorry. Since that was outside here, it's just sort of tacked onto the end over here. Does that make sense? Mm-hmm. So then I just do the calculations. Negative 4 times negative 3 is 12 plus 8, right? 7 plus 1 is 8. So it's 20. Paper.
Okay.
So 6 minus f of 5. So what I'm going to do is I'm going to put the 6 on the front and I'm going to subtract 2x minus 3, but I'm putting in the 5 where the x is. Does that make sense so far? So that's going to be 6 minus 10 minus 3, which is going to be 6 minus 7,
Which is negative 1.
which is negative 1. Okay.
Is that y?
That would be the value of y when x is 5 and I'm subtracting it from 6. So it's not really y exactly. It's just, it's saying if I have this function, I put 5 in there and I subtract it from 6, what's that equal? So here I have f of negative 1 plus f of 2. So here's f of negative 1. Oops, minus 3, not plus 3. Plus, that's this plus right here. And here's f of 2. So I have negative 2 minus 3 plus 4 minus 3.
I don't get like shit.
Whatever's in the parentheses replaces the x. And then whatever happens outside, you just sort of tack it on.
Okay.
So here, negative 1 replaced the x, and then I had to put a plus because I was doing 2 of them, and then 2 replaces the x. Got it?
Mm-hmm.
So negative 2 minus 3 is negative 5. 4 minus 3 is 1. So it's negative 4.